this problem, a man is skiing down a slope and we're asked to draw the free body diagram for him. The free body diagram will use a coordinate system that's tilted, where the y-axis is perpendicular to the slope and the x-axis is parallel to the slope. We are then asked to find the x acceleration of the man. To solve this problem, we will need to draw a free body diagram and we'll have to use Newton's second law. The forces acting on the skier are gravity, normal force, and kinetic friction. Gravity acts straight down. The normal force is perpendicular to the surface, in this case is perpendicular to the slope, and the friction force acts in the direction opposite to the direction of motion. So since the skier is going down the slope, friction acts up the slope. Notice that the coordinate system we're using has the y-axis perpendicular to the slope and the x-axis parallel to the slope. The normal force, therefore, is purely in the y direction, the friction force is purely in the negative x direction, and the gravity force now has components in both the y and the x direction. In order to find an expression for the x acceleration, we will need to know the normal force. To find the normal force, we write Newton's second law in the y direction. So we sum the forces in the y direction and set that equal to the mass of the skier times its acceleration in the y direction. Because we have a tilted coordinate system and the skier is moving down the slope, there is no motion in the y direction, so AY is equal to 0. We then sum the forces in the y direction, which in that case is the normal force and the y component of the gravity force. Through trigonometry, we know that this angle alpha between the y-axis and the gravity force is the same as the angle of the slope. The y component, then, of the gravity force is equal to mg times cosine of this angle alpha. Writing that in equation form, we therefore have the normal force minus the y component of the gravity force equals 0, and we can then solve this equation for the normal force, which we have written here. To find the skier's acceleration down the slope, we write Newton's second law in the x direction. So we sum all the forces that act in the x direction and set that equal to the mass of the skier times his acceleration, which we're trying to find. The forces which act in the x direction are the x component of the gravity force and the force of kinetic friction. We know from trigonometry that the x component of gravity is equal to mg times sine of this angle alpha. We therefore write the x component of gravity as mg sine alpha here. In the next step, we substitute in the definition of kinetic friction, which is the coefficient of kinetic friction, times the normal force. Then, because we have found an expression for the normal force previously, we substitute that into our equation and simplify so the masses all cancel, and we can then solve this equation for the x acceleration and arrive at this expression here involving the acceleration due to gravity and the angle of the slope and the coefficient of kinetic friction. We then substitute in the numbers given in the problem statement and evaluate to find that the skier's acceleration down the slope is 4.13 meters per second squared.